Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for the better preparation of your exams. So today, students, we will be solving JEE 2024 29th Jan Shift 2 paper. Okay. In this particular video, I'll be solving physics part of the paper. So here we go. The question number 31 of this series. This question says that two sources of light emit with a power of 200 watt. The ratio of number of photons of visible light emitted each source having wavelength 300 nanometer and 500 nanometer respectively will be. So student, this question is from the chapter of dual nature of matter and radiation. Okay, dual nature of matter and radiation. According to this question, we have to find the ratio of the number of photons. Students, we know that let us say in 1 second time, the energy stored will be P joules. Let us say in 1 second, the energy is P joules and the energy of one photon. And the energy of one photon is equals to hc over lambda. In 1 second, the energy is P joule, okay? And energy of one photon is what? hc over lambda. So the number of photons that are emitted per second will be equals to total energy P joule over the energy of one photon, that is hc over lambda. Since P is constant, H is constant, C is constant. So the number of photon is directly proportional to lambda. So here in this question, N1 over N2 will be equals to lambda 1 over lambda 2. So it will be equals to what? 300 nanometer over 500 nanometer. So N1 over N2, that is the ratio of number of photons, will be equals to 3 over 5. That is 3:5. So the correct answer is option D, 3:5. Okay. Now next question, question number 32. This question says that the truth table for the given circuit. We have to find among these four options the correct truth table. Okay. Now this question is from the chapter of electronic devices. Electronic devices. Now, according to this question, here we will get A. This is a NOT gate. So here we will get A bar. Okay. Here we will get B. And here also we will get B. Okay. Since it is a OR gate, so we will get, and it is a NAND gate. Okay. So here we will get A dot B. And here we will get A bar dot B. And it is a NOT gate. So the output Y will be equals to AB plus A bar B. Okay. So using Boolean algebra, Y output will be equals to A plus A bar into B. And A plus A bar, from the property A plus A bar equals to 1. So Y will be equals to B. Okay. So the truth table which is satisfying this equation will be, let us see from option A. Option A, if B is 0, the output must be 0. But here output is 1. So this is not the correct answer. In option B, if B is 0, Y is 0, B is 1, Y is 1, B is 0, Y is 0, B is 1, Y is 1. So our correct answer is option B. Okay. Now next question, question 33. This question says that a physical quantity Q is found to be depend on quantities A, B, C by the relation Q equals to A raised to the power 4 B cube over C square. The percentage error in A, B and C. Percentage error in A is 3%, B is 4% and C is 5% respectively. So we have to find the percentage error in Q by using error analysis formula. Error analysis. So we get del Q over Q will be equals to 4 del A over A plus 3 del B over B plus 2 del C over C. Now del Q over Q will into 100 because we have to find the percentage error. It will be equals to 4 delta A over A into 100 plus 3 delta B over B into 100 plus 2 delta C over C into 100. So percentage error in A is what? 3%, in B is 4% and in C is 5%. Now putting the values we get delta Q over Q into 100. It will be equals to 4 into 3 plus 3 into 4 plus 2 into 5. So it will be equals to 12 plus 12 plus 10. So our answer is 34%. So the percentage error in Q will be 34%. That is option C. Now next question, question 34. According to this question, in an AC circuit, voltage and current are given by V equals to 100 sine 100 t volt, okay, and I is given as 100 sine 100 t plus pi by 3 milliampere, okay. Now we have to find the average power dissipated in 1 second. 1 cycle, okay. So this question is from the chapter of electromagnetic induction and alternating current. Electromagnetic induction and alternating current. Okay. Now, comparing this equation with the standard equation, V equals to V naught sine omega t. So, V naught is 100 and omega is also 100. And comparing this with the standard equation, I naught sine omega t plus phi, where phi is the phase difference between these two, V and I. So the phase difference is phi equals to pi by 3 and omega is 100 and I naught is 100. So we have to find the power. So we know that the direct formula for power is equals to VRMS into IRMS into cos del phi. Del phi means phase difference between them. VRMS is what? V naught by root 2. V naught by root 2 is VRMS, okay? And IRMS is what? I naught by root 2. V naught is what? 100. V naught is 100. 100 by root 2 into IRMS is I naught by root 2 means 100 by root 2. And it is in milliampere, so into 10 to the power minus 3 into cos delta phi means cos pi by 3. Pi by 3 is the phase angle. Now solving it, 100 by root 2, 100 by root 2 means 10 to the power 4 minus 3 over 2 into cos pi by 3, 1 by 2. So the correct answer is 10 over 4, that is 2.5 watt. So the power dissipated in 1 cycle is 2.5 watt, means option C. Now next question, question 35. According to this question, the temperature of a gas having 2.0 into 10 to the power 25 molecules per cubic meter at 1.38 atm pressure. Atmospheric pressure is given 1.38. So this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. Now, according to this question, we know that the ideal gas equation is given as PV equals to nRT. Okay. So PV equals to N, and how we write this N? As N over Na, where N is the total number of molecules and Na is the Avogadro number into RT. Now this R over Na is what? K, Boltzmann constant. So P will be equals to N over V into KT, where K, Boltzmann constant, is R over Na. Okay. Now, so we have to find the pressure, we have to find the temperature. So pressure is equals to N over V into KT. Now putting the values, we get pressure is given how much? 1.38 atm, means 1.38 into 10 to the power 5. Okay. It is equals to N. Uh, uh, number of molecules is given as 2 into 10 to the power 25 into K, Boltzmann constant, 1.38 into 10 to the power minus 23 into T. We have to find the temperature over V, volume. Volume is what? 1. So we get temperature, solving this, we get temperature as 1.01, into 1.01 into 10 to the power 3 over 2. So temperature is 500 Kelvin. Okay, so the correct answer is A, 500 Kelvin. Next question, question 36. This question says that a stone of mass 900 gram is tied to a string and moved in a vertical circuit of radius 1 meter, making 10 RPM, 10 rotation per minute. The tension in the string when the stone is at the lowest point is. We have to find the tension in the string. And this question is from the chapter of kinematics. Now, solving this question as, suppose this is a circle, vertical circle, and a stone of mass 900 gram is tied to a string and it is moved vertically in a circle. So in this stone, let us say this is tied to a circle. So downwards force, gravitational force is acting in downward direction and tension force is acting in upward direction, and V, and a centripetal force is acting in this direction. Okay, so mass is given as what? 900 gram. 900 gram means 900 over 1000 kg. It means 9 over 10 kg. Okay, and R is given as 1 meter. So omega will be equals to 2 pi n over 60. So it will be 2 pi and 10 rotation per minute na, over 60. So omega angular frequency will be equals to pi by 3 radian per second. Now these forces balance out each other to tension force minus this downward force. It is equals to the centripetal force mr omega square. So tension force will be equals to mg plus mr omega square. So it will be equals to m is what? 9 over 10 into gravity 9.8 plus mass 9 over 10 into R1 into omega pi by 3 whole square. Now solving it, we get 8.82 plus 9 over 10 into pi square over 9. So it will be equals to, putting the value of pi 3.14. So 8.82 plus 9 cancels out each other, 1 over 10 into 3.14 whole square. So we get 8.82 plus 0.98. So it will be equals to 9.80 Newton. So the tension force acting on it is 9.80 Newton. So the correct answer is option B. Okay. Now next question, 37. The bob of a pendulum was released from a horizontal position. The length of the pendulum is 10 meter. If it dissipates 10% of its initial energy against air resistance, the speed with which the bob arrives at the lowest point is. We have to find the speed. So student, this question is from the chapter of oscillations and waves. Now, according to this question, there is a pendulum, okay, and the bob is released from the horizontal position. Let us say the bob is released from this and it is doing like this type of motion. It is doing like this type of motion. So at first, initially it is in horizontal position and now it is at this point, okay? So, and its length is given as what? L. Length is L, 10 meter. So according to this question, length is given as 10 meter. And according to this question, if it's dissipate 10% of a energy, initial energy is what? mgh. Initial energy is mgh, means mgl, L is the length. It dissipates 10% of its energy. So remaining energy is what? 1 minus 10% means 10 over 100. The remaining energy is 90 over 100 means 9 over 10. Okay. So mgl 9 over 10 mgl will be equals to half mv square. The gain in the loss in kinetic energy will be gain in potential energy. So it will be equals to 9 over 10 into mass 10 into gravity 10. Okay. mg 10 into 10 equals to 1 by 2. M cancels out each other to 9 by 10 into gravity 10 into length 10 half into v square. We have to find this speed. Na? So v square is equals to what? 9 over 10 into 10 into 10 into 2. So 10 cancels out each other. So v square equals to 180. So v will be under root of 180. That is 6 root 5 meter per second. So the speed with which the bob arrives at the lowest point means at this point its speed is given as 6 root 5 meter per second. So the correct answer is option A. Now question 38. According to this question, if the distance between object and its 2-time magnified virtual image produced by a curved mirror is 15 centimeter, we have to find the focal length of the mirror. So this question is from the chapter of optics. Okay. Now understanding this question as, let us say, according to this question, the object and its 2-time magnified virtual image. Magnified virtual image means this is a concave mirror. Okay. Magnified virtual image means concave mirror means, let us say this is a concave mirror. Okay. This is the principal axis. And 2 times magnified image means if the object height is this, so the image height is this. If the object height is h0, so the image height will be 2h0. Okay. And it's 2 time means if the distance is this object distance, so image distance will be 2x. Okay. So 2 and the what according to question, and it is forming the image at 15 centimeter means 2x plus x will be 15 centimeter means 3x equals to 15 centimeter. So x will be 5 centimeter. Okay. Now using the formula 1 over v plus 1 over u is equals to 1 over f. 1 over v is what? 2x. 1 over u is what? X, but with a negative signs according to sign convention into equals to 1 over f. So x is what? 5. So 1 over 2 into 5 minus 1 over 5 equals to 1 over f. So 1 over 10 minus 1 over 5 is equals to 1 over f. So 10, 1 minus 2 equals to 1 over f. So f will be equals to 1 over f will be equals to minus 1 over 10. So f will be equals to minus of 10. So the focal length is minus 10 centimeter. So the correct answer is option C, minus 10 centimeter. Okay. Now next question 39. According to this question, two particles x and y having equal charges are being accelerated to the same potential difference. Thereafter, they enter normally in a region of uniform magnetic field and describe circular path of radii R1 and R2 respectively. We have to find the mass ratio of X and Y. So this question is from the chapter of magnetic effects of current and magnetism. Okay. According to this question, we have to find the ratio of the masses of X and Y. Okay. Now, since we know that we have to find the ratio of what masses, na? So, R equals to mv over qb. R equals to mv over qb. And mv is what? P momentum. Since we know that P equals to mv, na? So P equals to, R is equals to P over QB. And P, in terms of, if we want to write this momentum in terms of the kinetic energy, how would we write it? We write P momentum as under root of 2m into kinetic energy over QB. Since kinetic energy equals to half mv square, na? mv square. So from this we write P equals to under root 2m ke over qb. So it will be equals to under root of 2m qv over qb. So this q cancels. Sorry, this is under root. Okay, this will not cancels out each other. So R will be equals to under root of 2m qv over qb. So everything is constant except mass. So this R is directly proportional to under root of mass. So M will be directly proportional to R square. It means the ratio of masses M1 over M2 is equals to R1 square over R2 square. Okay. So the correct answer is M1 over M2 equals to R1 over R2 square. So the correct option is option B. Now next question, question 40. According to this question, in a Young's double slit experiment, light from two identical sources are superimposing on a screen. The path difference between the two lights reaching at a point on the screen is 7 lambda by 4. Path difference is 7 lambda by 4. The ratio of intensities of fringe at this point with respect to the maximum intensity. Okay, we have to find the ratio of I over I maximum. So this question is from the chapter of wave optics. Let us try to understand this question with the help of a diagram. Okay, let us say these are two slits S1 and S2 and light are passing through it, and this is our screen. Okay, as we know that this is our center fringe where maximum intensity is from central fringe. Okay, so let us say here I maximum is the intensity and another and the rays are accumulated at other point. This is the intensity I naught having a path difference delta x equals to 7 lambda by 4. Okay, so we have to find the ratio of the intensities of I over I maximum. Okay, let I over I maximum. So now here delta x is given as 7 lambda by 4 and we know that path difference formula phi is equals to 2 pi over lambda into delta x. Okay, so it will be equals to 2 pi over lambda. This is relation between phase angle and path difference. This is phase angle and this is path difference. This is a common formula. Relation between phase angle, phase difference and path difference. Phi equals to 2 pi over lambda into delta x. So it will be equals to 2 pi over lambda into delta x is what? 7 lambda by 4. The phi will be equals to 7 pi by 2. Okay, phase difference is 7 pi by 2. Now we know that I is equals to I maximum into cos square phi by 2. This is the common formula for the intensities. Now I upon I maximum is equals to cos square phi by 2. See, this is a direct formula based question. We have to do nothing, just apply formula and we will get the desired answer. So phi is what? 7 pi by 2 into 2. So it will be equals to I over I maximum. It will be equals to cos square 7 pi by 4. So it will be equals to cos square. We can write 7 pi by 4 as 2 pi into pi by 4. Okay, 4 into 2, 8 pi minus pi. It eventually comes 7 pi by 4. So it will be equals to cos square pi by 4. Since according to quadratic system, here from 0 to pi by 2 or from 2 pi to pi by 2, when we subtract from 2 pi any angle, all the trigonometric functions comes positive. Okay, so if we subtract uh, 2 pi by 4 from 2 pi in case of cos, so it will be positive in first quadrant. Okay, so the here we get cos square pi by 4 and we know that pi by 4 is 1 by root 2. So cos square of 1 by root 2 is 1 by 2. So the ratio of I over I maximum is 1 by 2. This is our final answer. 1 by 2, option A is the correct answer. So students, our next question is question 41. A small liquid drop of radius r is divided into 27 identical liquid drops. If the surface tension is T, then the work done in the process will be, we have to find the work done. Okay, so this question is from the chapter of atomic and nuclei. So according to this question, a small drop of a liquid is divided into 27 identical drops. Means, let us say if we use the volume of the liquid, okay. So volume of one liquid having radius r will be 4 by 3 pi r cube. Since the liquid is in the form of a sphere, so its volume will be 4 by 3 pi r cube, where capital R is the radius. It will be equals to 27 into 4 by 3 pi r cube. Okay, so 4 by 3, 4 by 3, pi cancels out each other. So r cube will be equals to 27 r cube. Thus capital R will be equals to 3r, or we can say small r equals to r by 3. This implies that r square equals to capital R square over 9. Okay. Now, if the surface tension is T, then the work done in the process, we have to find the work done. So the direct formula for work done is equals to T tension into del A. Delta is what? Change in the area. So taking T as common and delta A. Delta is what? 27. Since it is a sphere, so 4 pi r square minus 4 pi capital R square. Okay. It will be equals to T 27 into 4 pi. Small r square is equals to capital R square over 9. So we will write capital R square over 9 minus 4 pi r square. Now solving it, it will be equals to T 9 3s are 27. So 3 into 4 pi r square minus 4 pi r square. So it will be equals to 4 pi r square, taking it common. So we get 3 minus 1, 2. 2 into 4, 8 pi r square t. So the work done is 8 pi r square t. Okay. So the correct answer is option A, 8 pi r square t. Now next question. This question says, a bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A such that it just completes half circle reaching the topmost point B. The ratio of kinetic energy. So this question is from the chapter of kinematics. Okay. It is saying that a bob of mass m is suspended by a light string of length L, and it is imparted a minimum horizontal velocity at the lowest point A. After completing its one half cycle, it reaches to the topmost point B. So here the velocity is VL and here the velocity is VH. Okay. Now we have to find the ratio of kinetic energy at point A and at point B. Now applying what? Energy conservation law. Applying energy conservation law between A and B. So at point A and B, if we apply energy conservation law, so energy at this point must be equal to energy at this point, means the energy at point A must be equal to energy at point B. So energy at point A will be kinetic energy half m VL square equals to at point B. Okay, so at point B, the energy will be half m VH square kinetic energy plus this downward force downward force energy mgh na, so it will be equals to half m vh square plus downward energy this mg plus this mg 2 mg, so mg into total length is this is L and this is also L, so it is 2L. Okay, now it will be equals to half mvl square will be equals to 2 mgl plus half mvh square. Since we know that the VL at point A is under root of 5gl, okay? Under root of 5gl. So, putting this value of VL here, we get half m 5gl. Since it is under root square will be 5gl equals to 2 mgl plus half m VH square. M cancels out each other. Now it will be multiplying whole equation by 2. We get 5gl, 4gl plus VH square. Okay. So 5gl minus 4gl is equals to VH square. So GL will be equals to VH square. So from this VH will be equals to under root of GL. Okay. Now the ratio of kinetic energy at point A to kinetic energy at point B will be equals to half m VL square. VL means 5GL whole square over half m under root of GL square, means VH square. Half m cancels out each other. It will be equals to 5GL over GL. GL cancels out each other. So the answer is 5 upon 1, means 5 ratio 1. So the correct answer is option B, 5 ratio 1. Okay. So the next question is 43. This says that a wire of length L and radius R is clamped at one end. If its other end is pulled by a force F, its length increases by L. If the radius of the wire and the applied force both are reduced to half of their original values, keeping original length constant, the increase in length will become. So this question is from the chapter of properties of solids and liquid. According to this question, if the force and the radius both are reduced to half of their original values, then we have to find the increase in length. Okay. Since we know that the Young's modulus is equals to what? Stress over strain. This is a very basic formula. Okay. And we know that force over area. Force over area is what? Young's modulus into elongation over the length. This is direct from the theory part, that force upon area is equals to Young's modulus into elongation over length. Okay. So force over area is what? F over area is pi r square, where small r is the radius. Okay. Small r is the radius. It is equals to Young's modulus y into elongation. Elongation is of L and original length is capital L. Original length is L and the length increases by small l, means elongation is of small l and length is capital L. Now from this, L is directly proportional to f over r square. Okay, because this and pi are constant, so L is directly proportional to f over r square. Now, according to question, the force and radius reduces to half of its their original value, means elongation L is directly proportional to half, means 1 by 2 of force, and 1 by 2 of radius means 1 by 4, 1 by 2 whole square. Na? This implies that L, new L dash, the increase in length is directly proportional to 2L, since this will become, L will become 1 by 2 into 4, to 2 to 4. So L dash will become twice of original length, means that increase in the length. The increase in the length will be 2L, 2 times. Okay. So our correct option is option D. Now, 44 question. According to this, a planet takes 200 days to complete one revolution around the sun. If the distance of the planet from the sun is reduced to 1/4 of the original distance, how many days will it take to complete one revolution? So this question is from the chapter of gravitation. According to this question, it is directly based on the what? Kepler's law of planetary motion. Kepler's law of planetary motion. Okay, and we know that what is Kepler's law of planetary motion? That T square is directly proportional to what? R cube. Now from question, it takes 200 days to complete one revolution around the sun. If the distance between planet and the sun is reduced to 1/4 of the original distance, then we have to find the number of days. Okay, it means T1 square over T2 square equals to R1 cube over R2 cube. Now T1 is 200, 200 square over T2 square is equals to what? R1 over R2 na. So R1 is what? One revolution around the sun, and if the distance of from the sun reduces to 1/4, means if this is R cube, this will be R by 4 cube. Okay, one revolution and 1/4 reduce, it is reducing 1/4 na, to R by 4. So it means 4 into 10 to, it means 4 into 10 to the power 4 over T2 square will be equals to R cube over R cube into 4 cube. R cube cancels out each other. So T2 square will be equals to 4 into 10 to the power 4 over 4 cube. Okay. Now T2 will be equals to, this we can write as 4 into 10 to the power 4 over 4 into 4 square. 4 cancels out. Now T2 square will be, T2 square, T2 will be 200 over 8. So T2 will be 25 days. So our correct answer is 25 days. Means option A. Now next question 45. A plain electromagnetic wave of frequency 35 megahertz travels in free space along the x direction. Okay, at a particular point in space and time, E is given as 9.6 J cap volt per meter. We have to find the magnetic field at this point. So this question is from the chapter of electromagnetic waves. Electromagnetic waves. There is a very simple formula for solving this question, and that formula is E equals to BC. Okay. Now, from this, E upon B will be equals to 3 into 10 to the power 8. We have to find the value of magnetic field. Magnetic field means B equals to E by C. And E is given what? 9.6 J cap volt per meter, na, and the frequency is given 35 megahertz. So there is no use of this frequency. We can directly solve this question by E by C. 9.6 over 3 into 10 to the power 8. So solving it, we get B equals to 3.2 into, solving it, we get B equals to 3.2 into 10 to the power minus A K T, K cap into T. So the correct answer is option A, 3.2 into 10 to the power minus 8 K cap into T. Okay. Now next question, question 46. In the given circuit, the current in the resistance R3. So this question is from the chapter of current electricity. According to this question, we have to find the current through R3. Okay. Now this resistor and this resistor, they are in parallel. So for this R2 and R3, the R equivalent will be 2 since they are in parallel. Na? So parallel means R equivalent will be equals to 4 into 4 over 4 plus 4 means 16 over 8. So R equivalent will be 2 for R2 and R3. And this R1 and this R equivalent and R4, they all are in series. So for this, R equivalent will be equals to 2 ohm plus this 2 ohm plus 1 ohm equals to 5 ohm. Now total potential is what? 10 volt. So the current through this whole circuit will be equals to V equals to IR. So I will be V equals to R. V is what? 10 volt over R is 5 volt. So current will be 2 ampere in the whole circuit. Now the current flowing through this is 2 ampere. So this 2 ampere current must be distributed in both the arms. So here also the current is 1 ampere and current flowing through this is also 1 ampere. So the current through the resistance R3 is 1 ampere. Okay, so the correct answer is option A, 1 ampere. Now question 47. A particle is moving in a straight line. Okay, the variation of position x as a function of time t is given as this. The velocity of the body when its acceleration becomes 0 will be. So this question is from kinematics. We are given with the position which is a function of time, and we have to find the velocity when the acceleration becomes 0. So x is given as t cube minus 6t square plus 20t plus 15. So velocity is what? Dx over dt. So it will be equals to 3t square minus 12t plus 20. Okay. And dv over dt is what? Acceleration. And its acceleration is becoming what? 0. So putting it equals to 0 and differentiating this v with respect to time. So we get 60 minus 12. And this must be equals to 0. So 60 will be equals to 12. So t will be equals to 2 seconds. Okay. So we are putting this value of t in v because we have to find the velocity, na. So velocity at t equals to 2 seconds will be equals to this. We have to put the value of t in this equation. 3 into 2 square minus 12 into 2 plus 20. So this will be 4, 3, 12 minus 12 to the 24 plus 20. So this will become 232 minus 24. So it will be equals to 8 meter per second. So our answer is 8 meter per second. Okay. So option B is correct. Now next question 48. N molecules of polyatomic gas F equals to 6 must be mixed with 2 moles of monoatomic gas so that the mixture behaves as a diatomic gas. The value of N is. So this question is from the chapter of kinetic theory of gases. Okay. according to this question, we have to find the value of n, means we have to find the number of moles. Okay, so F equivalent will be equals to N1 into F1 plus N2 into F2 over N1 plus N2. Okay, now according to this, N moles of polyatomic gas must be mixed with 2 moles of monoatomic gas. Let us say N1 be the moles of polyatomic gas. So for this, we have to write F1 and N2 be the number of moles of monoatomic gas. For this, we are writing F2. And there are 2 moles of monoatomic gas, means N2 is given as 2. Okay. For polyatomic gas, the value of F is given as 6. And for monoatomic gas, okay. For monoatomic gas, the value of F, degrees of freedom, is equals to 3. For diatomic, it is F equals to 5. And for polyatomic, the value of F is equals to 6, as given in the question also. Okay, given as 6. So this 1 mole of, so this n mole of polyatomic gas, when mixed with 2 mole of monoatomic gas, they form a diatomic gas. Okay, means this F equivalent is of what? Diatomic gas. And for diatomic, the value of F is what? 5. So we write 5 is equals to this N1. We have to find this N1 into F1. F1 for polyatomic gas, it is 6 plus N2. N2 is given as 2 into F2. For monatomic gas, F is 3 over N1 plus N2. Now, just solving it, we will get our desired answer. So 5N1 plus 10, it will be equals to 6N1 plus 6. So 5N1 minus 6N1 will be equals to 6 minus 10. Minus N1 will be equals to minus 4. Thus, N1, number of mole for polyatomic gas, is what? 4. Okay. So the correct answer is option C, 4. Now 49 question. Given below are 2 statements. Statement 1 is most of the mass of atom and its all positive charge are concentrated in a tiny nucleus and the electrons revolve around it. It's Rutherford model. And second statement is what? An atom is a spherical cloud of positive charges with electrons embedded in it. It is a special case of Rutherford model. Now, this question is from the chapter of atomic and nuclei. As we all know, the famous Rutherford model. According to Rutherford atomic model, most of the mass of an atom and all its positive charge is concentrated in the tiny nucleus, okay? And the electron revolves around it. According to Thomson atomic model, atom is a spherical cloud of positive charge and with electron embedded in it. So, statement second is wrong and statement 1 is true, since this is the Rutherford model, which is a true statement, and this is a Thomson model, not Rutherford model. Okay, so the correct option is option C, that is statement 1 is true and statement 2 is false. Now 50 question. An electric field is given by this Newton per Coulomb. The electric flux through a surface area 30 iota meter square lying in YZ plane in SI unit. Okay, so this question is from the chapter of electrostatics. Okay, according to this, the electric field is given as 6 iota cap plus 5 J cap plus 3 K cap Newton per Coulomb. Okay, and electric flux, we have to find the electric flux and the surface area is given as 30 iota meter square. So flux phi is what? E dot A. So phi will be equals to E is 6 iota cap plus 5 J cap plus 3k cap into A. Area is given 30 iota cap. Now solving it, we get 6 into 30 equals to 180. So the correct answer is 180. Option C. So students, the next question is 51. According to this question, two metallic wires P and Q have same volume and are made up of same material. If their area of cross sections are in the ratio 4:1 and force F1 is applied to P, an extension of delta L is produced. The force which is required to produce same extension in Q is F2. We have to find the value of F1 over F2. So this question is from the chapter of properties of solids and liquids. Okay. According to this question, we have to find the ratio of the force. Now, students, we know that Young's modulus, the direct formula for Young's modulus Y is equals to stress over strain, stress over strain. So this stress will be equals to strain into Young's modulus. Okay. So stress is what? Force over area. This will be equals to Young's modulus into strain. Strain is what? Elongation over original length. Okay. Original length. Now elongation means extension. According to this question, elongation means extension. Extension over length. Okay. Now force over area. F over A is equals to Young's modulus Y into elongation. Extension is how much? Delta L over length. Original length is what? L. Okay. Now delta L over L. Okay. So from this, delta L over L will be equals to F upon area into Y. Okay. So delta L extension will be equals to F into L over A into Y. And we know that volume is equals to area into length. Okay. So L will be equals to V over A. Now put this value of L here. So we get delta L will be equals to F into V over A into Y. Okay. So delta L will be equals to FV over A square into Y. Now since Y and V is same for both the wires, okay, according to question, the wire have same volume and are made up of same material. So they will have same value of Y as well as same value of V. Okay. Since Y and V are same. So delta L will be directly proportional to F over A square. Okay. So now delta L1 over delta L2 will be equals to F1 over A1 square over F2 over A2 square. Okay. It means delta L1 over delta L2 will be equals to F1 over A1 square into A2 square over F2. Now, according to question, they if if their area of cross sections are in the ratio 4:1 and force F1 is applied to P, an extension of delta L is produced. The force which is required, we have to find force now. So according to this question, extension are same, delta L1 equals to delta L2. Therefore, F1 over F2 will be equals to A1 square over A2 square. So it will be 4:1 means 4 over 1 square. So F1 over F2 is equals to 16. This is our final answer. Okay. So the ratio of force F1 over F2 is 16.
Now, next question 52. This question says that a horizontal straight wire 5 meter long extending from east to west falling freely at right angle to horizontal components of Earth's magnetic field 0.60 10 to the power minus 4 Weber meter per meter square. The instantaneous value of EMF. We have to find the EMF when the velocity is 10 meter per second. So this question is from the chapter of electrostatics. So according to this question, the magnetic field is given as what? 0.60 into 10 to the power minus 4, and we have to find the induced EMF. So the direct formula for induced EMF E is what? BVL, magnetic field into velocity into length L. So it will be equals to 0.60 into 10 to the power minus 4 into velocity is 10 meter per second into L. L is what? 5 meter long. 5. So its answer will be 3 into 10 to the power minus 3 volt. Okay. 3 into 10 to the power minus 3 volt. Now next question 53. Hydrogen atom is bombarded with electrons accelerated through a potential difference of V, which causes excitation of hydrogen atoms. If the experiment is being formed at T equals to 0 Kelvin, the minimum potential difference need to observe any Balmer series lines in the emission spectra will be alpha over 10. We have to find the value of alpha. Okay, so this question is from the chapter of atomic and nuclei physics. So it is saying about the Balmer series line. Balmer series mean Lyman Balmer spectra. Na atomic spectra is what? Lyman Balmer Paschen, then bracket, and then P fund. Okay, so it is asking about the Balmer series line. The minimum potential difference. So Balmer series mean n equals to 2. Okay. So minimum potential difference occurs when, for minimum potential difference, the electron has to make transition from 3 to 2. Okay. But first electron has to reach to n equals to 3 from the ground state. Let us say for minimum potential difference. For minimum potential difference, the transition must be from n equals to 3 to n equals to 2. But for this transition, the electron must have to reach from ground state directly to n equals to 3. So basically, at first, energy bombarding electron should be equal to the energy difference of n equals to 3 to n equals to 1 state. Okay. Minimum potential difference will occur when the electron gets transmitted from n equals to 3 to 2. But for this n equals to 3 to 2 n equals to transition, the electron must reach from ground state to n equals to 3. So the bombarding electron should be equal. So the energy of the bombarding electron should be equal to the energy difference between n equals to 3 to n equals to 1. So for this, and we know that the energy difference delta E is equals to 13.6 over n square into E. So it will be equals to, and it comes into electron volt. Now this comes into electron volt. So 13.6 over 1 over n square. 1 over n square means 1 over 1 square minus 1 over 3 square into E. It will be equals to electron volt. Okay. So E cancels out each other. So it will be equals to 13.6 into 9 minus 1 over 9 equals to volt. So it will be 13.6 into 8 over 9. So V will be equals to 12.09 volt. So approximately 12.1 volt. So alpha is equals to 12.1. So sorry, alpha alpha will be equals to 1 to 1 over 10. Now we have to compare alpha over 10. So alpha will be equals to 121. This is our correct answer. Okay. Alpha is 121. Now next question. 54. A charge of 4 microcoulomb is moving with a velocity of 4 into 10 to the power 6 meter per second along the positive y direction under a magnetic field B of strength 2 k cap T. So the magnetic field is along the k direction, k cap, okay? The force acting on the charge is x iota cap, and we have to find the value of x. So this question is from the chapter of current electricity. Now the question is saying that the charge is along positive y direction, okay? The charge is along positive y direction. So Q is given as 4 microcoulomb and V is given as velocity 4 into 10 to the power 6 j cap meter per second, okay? And magnetic field is given as 2 k cap into T, and we know that the force acting on the charge having velocity v in magnetic field B is given as q v cross B. This is the famous formula, Lorentz force, okay? So it will be equals to Q is given as 4 microcoulomb, 4 into 10 to the power minus 6 coulomb into V. V is what? 4 into 10 to the power 6 J cap, okay? Into B is what? 2 into K cap. And J cap cross K cap is what? Iota cap. So it will be equals to 4 into 4, 16 into 2, 32. So 32 and minus 6 plus 6 equalize. So it will be 32. J into K is what? Iota cap. So the force is 32 iota cap Newton. So the value of x is 32. Okay. So the value of x is 32. Now next question 55. A simple harmonic oscillator has an amplitude A and time period 6 pi second. Assuming the oscillation starts from its mean position, the time required by it to travel x equals to a to x equals to root 3 by 2a will be pi over x, as where x, we have to find the value of x. So this question is from the chapter of oscillations and waves, okay? So students, for a simple harmonic oscillator, okay? So this question is from oscillations and waves. Oscillations and waves. So students, for a simple harmonic oscillator, we know that, let us say, this is a simple harmonic oscillator doing SHM motion. So at first, it is at its lowest position. And when it do 2 and 4th motion, it goes like this. Okay. 2 and 4th motion. Then again comes back to this. And then comes again, these are the extreme position, and again comes back to its lowest position, okay? Let us try to understand it as, let us say at first at t equals to 0 second, the bob means the simple harmonic motion starts from this position origin, then it goes to its extreme position, then came back to lowest position, then again goes to its extreme position, then came back to its minimum lowest position. So like this, it do simple harmonic oscillations, okay? So this is the sinusoidal wave na. So it is a sine function if it starts from the origin, so it is a sine function. But according to question, it has an amplitude. A simple harmonic oscillator has an amplitude A and time period is 6 pi second. Assuming that the oscillation starts from its mean position, so we have to find the time required to travel a distance of root 3 by 2a. Let us say, according to this question, at first the particle is at the point this, having an amplitude A and doing simple harmonic motion, it goes like this, then this and this. So this is a cos function wave na, cos function. So according to this, x will be equals to a cos omega t. Okay, x will be equals to a cos omega t, and time, and when it is starting from here, so time taken is 6 pi second. And it is asking about if x is equals to root 3 by 2a, so the time required to travel. Let us say when at starting point x equals to a cos omega t, now the x is equals to root 3 by 2a. Root 3 by 2a means root 3 by 2a is equals to a cos omega t. This a cancels, so root 3 by 2 will be equals to cos omega t, and cos 60 is equals to root 3 by 2. Cos root cos 60 is equals to root 3 by 2. It will be equals to cos omega t, and it will be equals to pi by 6 omega t. Okay. Now omega is what? 2 pi by t. So t is here what? T is 6 pi second. So omega will be equals to 2 pi over 6 pi. This pi cancels. 2 3 is 6. So omega will be equals to 1 by 3. So pi by 6 is equals to 1 over 3 into t. So t will be equals to 3 pi by 6 means pi by 2. So the time required is pi by 2 seconds. So the value of x here is 2. Now next question. In the given figure, the charge is stored in 6 microfarad capacitor when points A and B are joined by a connecting wire is, we have to find the charge stored. Okay, we have to find the value of Q. So this question is from the chapter of electrostatics. So we know that in a steady state condition, the charge through the capacitor, we do not consider current flowing through the capacitor. So this circuit will look like, let us say this is 6 ohm and it is joining the point A to B in a steady state condition. And now this is resistor having resistance 3 ohm and it is connected to a battery. Okay. So the current will flow like this. Okay. According to this, the 6 ohm and 3 ohm resistors, they are in parallel. So R equivalent will be 1 over 6 into 3 over 6 plus 3 means 18 over 9. So it will be 2. From Ohm's law, V equals to IR. So I will be equals to V over R. Okay. Now, sorry, these are in series, not in parallel. These are in series. So series means direct 6 plus 3 equals to 9. Sorry. These are in series. So 6 plus 3 equals to 9. Okay. Now, so the next question is 56. In the given figure, the charge is stored in 6 microfarad capacitor. When points A and B are joined by a connecting wire is, we have to find the charge in terms of microcoulomb. Okay. So this question is from the chapter of electrostatics. Electrostatics. So according to this question, we have to find the charge. Okay. Now, suppose let us say this capacitor, this whole circuit is in steady state condition. So in a steady state condition, no current flows through the capacitor. So this diagram will look like this. This is 6 ohm resistor and this is point A. Let us join this point A to point B, and this is 3 ohm resistance. Okay, so the current will flow like this. No current will flow from these two capacitors. Okay, now this is 9 volt and this is 0 volt. Okay, so these two are in series, so total resistance will be equals to 9 ohm. Now since voltage is always divided in the ratio of the resistances, so here will be 6 volt voltage and here will be 3 volt voltage. Okay, if here across the resistor 6 ohm, if the voltage is 6 volt, then here also across this capacitor 6 microfarad, the voltage will be 6 volt. Okay, so applying now the charge formula, Q equals to C into V, when C is 6 microfarad means 6 into 10 to the power minus 6 and voltage is 6. So 6 into 6, 36 microcoulomb. So our answer is 36 microcoulomb. Now next question 37. In a single slit diffraction pattern, a light of wavelength 6000 angstrom is used. The distance between the first and the third minima in the diffraction pattern is found to be 3 millimeter when the screen is placed in 50 centimeter away from the slits. We have to find the width of the slit. Okay, so this question is from the chapter of wave optics. So let us draw this question as, let us say this is the slit. Okay, be its width of the slit, and now the light rays are coming from it. This is the screen, and these are the two angles that is made by the light ray when it is passing through the slit. Okay, this is point A, this is point B. This distance is y1, and let the distance between the slit and the screen be capital D. Okay, now since it is asking for the minimal conditions now, so it is asking for minimal conditions. So for nth minima, this is from the direct theory part. From for nth minima, we know that b sine theta is equals to n lambda. Okay, now we are considering this theta is very small, so this sine theta turns to tan theta for small theta. So b tan theta will be equals to n lambda. Okay, B tan theta. Tan theta is what? Y over D. So Y over D equals to N lambda. Okay. So from this for nth minima, Yn is equals to N lambda D over B for nth minima. Now we will use this formula to solve our question. Yn equals to N lambda D by D. Okay. Now from the question, let us say at point B, the first minima is forming at point B. First minima, okay? And the third minima is forming at point A. According to question, the first and the third minima is forming na. So at point B, first minima is at point B and third minima is at point A, okay? So Y3, since at point A, third minima is forming, so y3 will be equals to 3 using this formula lambda d over b. Okay, and y1 for first minima, it will be equals to 1 into lambda d over b. Okay, now their difference delta y will be equals to y3 minus y1, so it will be equals to 2 lambda d over B. So delta y is given as what? 3 millimeter, na? The distance between the first and the third minima in the diffraction pattern is found to be 3 millimeter. So their difference is what? 3 millimeter. So 3 millimeter means 3 into 10 to the power minus 3 meter. It is equals to 2 into lambda. Wavelength of the light is given as 6000 angstrom. So 6000 into 10 to the power minus 10 meter into capital D. Capital D is the distance between slit and the screen. The distance between slit and the screen is 50 centimeter. 50 centimeter means 50 into 10 to the power minus 2 meter over B. This is what we have to find. So B will be equals to 2 into 6000 into 10 to the power minus 10 into 50 into 10 to the power minus 2 over 3 into 10 to the power minus 3. So 3, 2, it will be equals to 5, 4 is 20 into 10 to the power 3 plus 1, 4 minus 10 minus 2 plus 3. So solving it, we get 2 into 10 to the power 4, 5, 6, 7 minus 12 plus 1. So it will be equals to 2 into 10 to the power minus 4. Okay. So B, comparing it with the given equation, width of the slit is into 10 to the power minus 4. Comparing it with the given equation, x into 10 to the power minus 4. So x will be 2. Okay. Now next question 58. In the given circuit, the current flowing through the resistance 20 ohm is 0.3 ampere, while the ammeter reads 0.9 ampere. So the value of R1 is, we have to find the resistance value through R1. Okay, so let us say this is point A and this is point B, and this question is from the chapter of what? Current electricity. Current electricity. Okay, now these are point A and this is point B. So I1 is given as what? 0.3 ampere, and we know that from superposition theorem, I1 at junction point, I1 plus I2 plus I3 will be equals to 0.9 ampere. Since the total current in the circuit is 0.9 ampere, na? So from this 0.9 ampere current coming from here, it will be get distributed in equally in three parts. So this I1 current plus I2 current plus I3 current will be equals to 0.9 ampere. Let us say this is I1 current, this is I3 current, and this is I2 current. So I1, I2, I3 will be equals to 0.9 ampere. So VAB, potential across AB, will be equals to I1 into 20 ohm. It will be equals to 20 into I1. I1 is given as 0.3 ampere. So VAB will be 6 volt. Okay. Now I2. I2 will be equals to 6 volt over 15 ohm. So it will be equals to 2 over 5 ampere. Okay. Now, since I1 plus I2 plus I3 is equals to 9 over 10 ampere, means 0.9 ampere, na? So I1 is what? 3 over 10 plus I2 is what? 2 over 5 plus I3 is equals to 9 over 10 ampere. Okay. So I3 will be equals to 9 over 10 minus 7 over 10. So I3 will be equals to 2 over 10, means 0.2 ampere. Okay. So I3 into R1 will be equals to 6 volt. So I3 is 0.2 into R1 equals to 6 volt. So thus R1 will be equals to 6 over 0.2. It means 30 ohm. So this R1 is of 30 ohm. Okay. Now next question 59. A particle is moving in a circle of radius 50 centimeter in such a way that at any instant the normal and tangential component of its oscillation are equal. The normal and tangential component are equal. Okay. So if its speed at t equals to 0 is 4 meter per second, the time taken to complete first revolution will be 1 over alpha into this. We have to find the value of alpha. So this question is from the chapter of kinematics. According to this question, the normal acceleration and tangential acceleration are equal. So normal acceleration is what? V square over R, and tangential acceleration is del V over del T. Okay. So integrating both sides, left hand side and right hand side, and this will be, we can write this as V square over uh sorry, we can write it as dV over V square equals to dt over R. Okay. This is equation 1. Now integrating this equation from limit 4 to V. So dV over V square is equals to 0 to T dt over R. Since at t equals to 0, the velocity is 4. At t equals to 0, the velocity is 4. So integrating from 0 to t and 4 to V. Now it will be minus 1 over V. Limit is from 4 to V. It will be equals to T over R. Okay. Now this will become minus 1 over V plus 1 over 4 equals to 2t. So V will be equals to 4 over 1 minus 8t. Okay. And velocity is what? dr by dt means ds. We can write it as ds over dt na. So this 4 over 1 minus 8t is equals to ds over dt. Now again integrating it, we get 4 0 to t dt over 1 minus 8t will be equals to 0 to s ds. So we get, and since s is equals to 2 pi r the circumference, so and r is given as 50 centimeter means 0.5 meter, 0.5 meter, so it will be equals to 2 into pi into 0.5 means pi. Okay, now putting the value, we get 4 into log of 1 minus 8t, and the limit is from 0 to t over minus 8 will be equals to pi. This will become s, and the value of s is pi. So we get log of 1 minus 8t is equals to 4 to the 8 minus 2 pi. Okay. So 1 minus 8t is equals to e to the power minus 2 pi. So 8t is equals to 1 minus e to the power minus 2 pi. So t becomes 1 minus e to the power minus 2 pi over 8 second. So comparing it with the given equation is given as 1 over alpha 1 minus e to the power minus 2 pi. So the value of alpha is 8. Okay. Now next question. A body of mass 5 kg moving with a uniform speed 3 root 2 meter per second in xy plane along the line y equals to x plus 4, the angular momentum of the particle. Angular momentum. Okay, so this question is from the chapter of rotational motion. Rotational motion. The given equation of the line is y equals to x plus 4, means y minus x minus 4 is equals to 0. Let us say if d1 is the perpendicular distance of the line from the origin. Let us say d1 is the perpendicular distance of the line from the origin. Then did d1 become from the distance formula minus 4 over 1 square plus 1 square. Okay, since y equals to x plus 4 na, so y minus x will be equals to 4, or we can write it as x minus y equals to minus of 4. So using distance formula, d1 will be equals to this minus 4 over under root of these squares, 1 square plus 1 square. So it will become 2 root 2 meter. 2 root 2 meter. Okay. So angular momentum L will be equals to mvr, means mv into d1. So it will be equals to m. M is what? 5 kg over v 3 root 2 meter per second. So 5 into 3 root 2 meter per second into d1 is 2 root 2 meter. So 2 root 2. So solving it, we get 60 kg meter square per second. So the angular momentum is 60 kg meter square per second. Okay.